Hi and welcome to our tutorials on VG software. In this video, I'll guide you through working with point clouds in VGMetrology. Here's the workflow we'll follow. Import the point cloud into VGMetrology, which will automatically convert it into a mesh. Import the CAD model and align the mesh to the CAD. On the CAD model, create linear dimensions to measure a borehole. Use the multi-apply function to copy this measurement to the other boreholes on the cube. Transfer the measurements from the CAD to the mesh. On the mesh, perform a nominal-actual comparison. And finally, generate a comprehensive report. By the end of this tutorial, you'll know how to efficiently handle point clouds and create accurate measurements in VGMetrology. Let's get started. Importing point clouds into VGMetrology is straightforward and done with a few clicks. In the software, I'll go to File, Import, Point Cloud. I'll select the file. In the Import dialog, I'll click on Import. As you can see, when importing the data, VGMetrology will automatically create a triangle mesh. I'll click on Generate. And voila, my mesh is now in the scene. Now let's bring in the CAD model and align it with the mesh. I'll go to File, Import, CAD, and select the file. I'll go for a medium mesh accuracy and complete the import. And once the CAD model is in the scene, I can align the mesh to it. I'll use the best fit alignment option. To get the most precise result possible, I'll increase the quality level to 50 and complete the alignment. Perfect! The mesh and CAD are now aligned, and we're ready to move on to the measurement tasks. I will perform the measurements on the CAD model, and then copy and paste the measurements from the CAD model onto the mesh. For a better overview, I'll make the mesh invisible. Now let's see how we can tolerance the diameter of the boreholes on this side of the cube, according to this example drawing here, and using the linear sizes function. First, I'll create a cylinder in one of the boreholes. Then I'll open the linear sizes dialog. According to the drawing, the nominal diameter is 8 mm, with a tolerance of plus minus 0.1 mm. This is an envelope requirement. Once all that is set, I click Create, and the feature is generated. Now, to apply this dimensioning to the other 9 boreholes, I'll use the multi-apply function. This function allows me to copy and paste coordinate measurement elements by creating a pattern in the coordinate system. In the scene tree, I copy and paste the coordinate measurement entry. This opens the CM template import dialog. The first tab shows the coordinate system I'm working in. I'll switch to the multi-apply tab. Here I'll select the multi-apply mode. I can choose between translation and rotation. For this case, I'll go with translation. Then I can define the pattern within the current coordinate system. 2 copies in X direction, spaced 40 mm apart, and 5 copies in Z direction, spaced 15 mm apart. Let's check the preview. Looks good. The list here confirms that 10 copies have been created. I'll delete the first one, since this is the copy of the original feature that I already have. Then I'll click on OK. And voila! The geometry element and feature have been applied to all boreholes according to the specified pattern. And now that the measurements are on the CAD model, let's transfer them to the mesh. In the scene tree, I'll turn off the visibility of the CAD model and make the mesh visible. Then I simply copy and paste the measurement plan from the CAD model to the mesh. I confirm the dialog. And I'm done. The measurements have been successfully transferred to the mesh. Okay, Now let's see how we can perform a nominal actual comparison between the mesh and the CAD model. I'll select the mesh in the scene tree. Then I'll go to Analysis, Nominal Actual Comparison. In the Analysis dialog, I'll specify the maximum deviation I am looking for. In my case, I will stick to the default value of 0.3 millimeters. I want to have annotations for the minimum and maximum deviations. And I'll specify the following tolerances. 95% of deviations must be smaller than 0.1 millimeters. The minimum deviation must be larger than minus 0.25 millimeters. And the maximum deviation must be smaller than 0.25 millimeters. Then I'll run the analysis. Once the calculation is complete, I can immediately see the tolerance status of the analysis. To explore the results, I can take a look at the deviation histogram, which shows the distribution of deviations. I can also check the cumulated histogram for a statistical overview of the deviation distribution. And in the 3D view, I get a clear color-coded visualization of the deviations between the CAD model and the mesh. When I hover over the object, I can see the exact deviation value at any specific location. In the case of my cube, the largest deviations appear in the boreholes. Let's check that out. I'll switch to one of the 2D windows and locate the maximum deviation. And when I now make the CAD model visible, I can clearly see that the depth of the borehole in the mesh differs significantly from the depth defined in the CAD model. Okay, now that I have performed my measurement tasks and analysis on the mesh, I want to have the results in a comprehensive report. For this report, I would like to have some nice images. So let's create some views. I'll create 2 views of the nominal actual comparison results. And another view of the coordinate measurement results. And once I have my views, I can proceed to create the report. Since version 2026.1, I can opt between a project report or a part report. Since a part report allows me to include the report in an evaluation, I'll go for this option. To create a part report, I need to select the part in the scene tree. Then I'll open the Reporting tab and select Create Report. I'll specify what I want to include in the report. And if I want, I can select a customized report layout. Then I'll click on Create. And this is my report, including the views. An interactive 3D result. And all the information that I had specified. And that brings us to the end of the workflow. With VG software, you can easily handle a wide range of measurement and GD&T tasks, as well as analysis, not only on volumes, but also directly on point clouds. Have fun exploring and trying it out on your own. I hope you enjoyed this video. You'll find a list of all our tutorials on our documentation landing page via Help, Show Tutorials. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts. And stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.